What if your car could avoid an accident before you even saw the danger? Or your wearable could alert your doctor before a serious heart issue occurs? That's the power of edge computing. But what exactly is edge computing? Simply put, it's processing data closer to where it's generated, rather than sending everything to a centralized server. That means faster insights, reduced latency, and less bandwidth wasted moving data back and forth. For professionals across industries, understanding this technology has become essential for staying competitive and supporting digital transformation. Edge computing is already everywhere, often in ways you don't even notice. Take self-driving cars, for instance. Companies like Tesla and Waymo process sensor and camera data locally in the car. It allows the vehicle to make split-second decisions, braking, steering, or avoiding obstacles without waiting for the cloud. This keeps drivers safe in real time. In healthcare, wearable devices like the Apple Watch monitor heart rate or detect irregular rhythms instantly. Continuous glucose monitors track blood sugar levels and alert patients or doctors immediately if intervention is needed. These devices rely on edge computing to provide life-saving, real-time insights. Even factories are leveraging edge. Siemens and GE use sensors on industrial equipment to detect anomalies and predict failures before they happen. When a motor starts overheating, an edge system triggers an alert instantly, preventing costly downtime and keeping production on schedule. And retail is getting in on the action too. Amazon Go stores processed video feeds and sensor data locally to enable just walk out shopping. Customers grab what they need, and the system updates inventory, recommends products, and completes transactions automatically, all in real time thanks to edge computing. From cars to wearables, factories to stores, these examples show that edge is changing the way work gets done across industries. So why should professionals care? Because this technology impacts how decisions are made, how data flows, and how teams build products and services. Understanding the basics gives you a framework to identify opportunities and support digital transformation initiatives. It lets you make better, faster decisions in your role, even if you're not directly programming sensors or building networks. Knowing the capabilities and limitations of edge can help you ask smarter questions, design better workflows, and collaborate more effectively with technical teams. So let's look at some roles where edge computing is becoming integral. Data scientists use edge-generated data to train models that are more accurate and timely. AI engineers deploy algorithms that run efficiently on distributed devices. Cybersecurity analysts secure a growing number of endpoints, often with limited bandwidth or processing power. Systems engineers design networks that connect edge devices reliably, while operations managers use it to optimize logistics and monitor production in real time. Retail strategists leverage edge data for personalized in-store experiences. And healthcare IT teams ensure patient data is processed securely and immediately. Edge computing is touching nearly every profession where real-time data matters. Imagine a day in a factory. Sensors detect that motor is overheating. And instead of sending data to a cloud server and waiting minutes for analysis, edge devices process the data locally and trigger an immediate alert. A maintenance technician receives a notification, a supervisor adjusts workflow, and downtime is avoided. That same principle applies in hospitals, transportation networks, and retail stores. Or picture a nurse receiving a real-time alert from a patient's wearable device. Or a store manager adjusting inventory instantly as sensor data signals a hot product trend. Faster, smarter decisions at the source. That's edge computing in action. And the future is even more exciting. As 5G expands, devices become more connected, and AI gets smaller and smarter, edge computing will handle more complex workloads in real time. Autonomous vehicles will rely on it for split-second navigation decisions. Smart factories will become even more predictive and adaptive. Healthcare devices will monitor patients continuously, feeding insights to doctors without overwhelming networks. Professionals who understand the role of edge in these scenarios will have a strategic advantage. They'll know how to harness data where it matters most. Getting started doesn't mean you need to become a network engineer or hardware specialist. Understanding the concepts, possibilities, and limitations is enough to provide value in most roles. It's also helpful to learn what latency is, why bandwidth matters, how data is processed locally, and how security considerations differ from cloud systems. Explore real-world examples like smart vehicles, wearable health monitors, connected warehouses, and AI-enabled retail experiences. And familiarity with platforms like AWS Greengrass, Azure IoT Edge, or Edge AI frameworks can give you context without requiring deep technical expertise. Edge computing is quietly changing the way organizations operate. Professionals who understand it will be the ones identifying new opportunities, supporting transformation initiatives, and making faster, smarter decisions. Even if you never touch a sensor or configure a local server, knowing how edge computing works gives you a lens to see what's possible and how to apply it in your role. Edge computing is the hidden layer that makes digital transformation work. The professionals who recognize its power today will be the ones shaping how businesses operate, innovate, and compete tomorrow. And it's not just for engineers. How do you think edge computing can change your work? Drop a comment, share an example, or let us know which industry you think will be transformed first. Learning the basics is your first step towards staying relevant and ahead in a world that's moving faster than ever.